All right. Well, thank you, Tim, and thank you, Mark, for obviously the vision and creating the culture within Facebook that gave us the opportunity to create something like Open Compute. We had a little change of schedule, obviously. Greg Huff was supposed to be on before. Greg Huff from LSI is going to be coming up next. He's going to be talking about the strategic commitment that LSI is making to the Open Compute project. So I'm really excited to announce them as a new contributing member. Greg, please come on up. Thanks.
So as Frank mentioned in his keynote earlier and repeated just now, we are actually a new member of Open Compute Foundation and a contributing member as well. So we started getting excited about open concept innovation a little over 2 years ago, roughly around that time frame. And I'm going to walk you through the causality, right? As a storage technology company, what motivated us to get into open ecosystem innovation, what's the driver for us, what do we expect to get out of it, and it's all really tied to our view of how services and data centers are going to evolve over time, right? So we spent some time thinking about what to call this pitch, and we came up with this kind of, I think, interesting term called data-centered. And what's interesting about it is you can interpret it two ways depending upon which emphasis you put the syllable on. And so, and the even better part is they're both correct. And so I'm going to walk through that a little bit with you and explain why we use that term. So first is, I think it's been widely known, and a number of the presenters, including the last interview, have talked about the richness of interaction, right? The growth in tablets and smartphones, data-connected services, wearables coming, a great deal of things aimed at people that are delivered online over a live data connection. And the growth of that is, I think, not questioned. If you look at leaders in this space and Ericsson or other guys in the mobile broadband business and the projected rate of growth that they see coming through the years in the future, it's just tremendous, right? And then also this term Internet of Things has come up quite a few times. A lot of companies, Cisco, et cetera, talk about their vision for this. And, essentially not going to get into this and debate it with them. We agree this is interesting and going to happen. But I think people lose sight of what opportunities there's going to be in this world of connected devices and connected data. So without getting into too many examples, let me give you one that I think is just illustrative, right? So let's say you had some regional area, some county or state or some part of the world where you were collecting sort of fine-grained information about climate, right? Soil samples for moisture, humidity, temperature, et cetera, over time. That might be very useful if you could do analytics on it to something like a municipal water authority to manage irrigation in a time of drought, right? To make sure there was no overwatering, underwatering, et cetera, and that everybody sort of got their fair share of a scarce resource. If you had that data back over time, it could be actually very useful for the farmers themselves to know when to plant, harvest, irrigate, fertilize. It could increase yield, drive up crops. If you had that data over a broader geographic area, then that even maybe becomes interesting to commodities traders who are interested in futures options on the underlying crops that are going to be on that land where the climate data is being digested. And, once again, it's kind of a contrived example, but I guarantee you that one's going to happen, and thousands of others that we haven't thought of. So the key here is that a lot of innovation, a lot of value creation, a lot of optimization in the future is going to be centered on the data that you can gather and correlate and extract some insight from. So that's one way to interpret the term data-centered. The other one is to step back and say, none of those interesting things actually occur on the end. It's not going to happen on the wearable or on the tablet. It's not going to happen on the data internet connected meteorological station in a field. It's got to happen somewhere, right? And so the data center, at whatever scale or scope or deployed it is the place that this is going to happen, right? And so why can't it happen out at the ends? And it's pretty straightforward. So first is, to really get this interesting outcomes, you need nearly limitless depth and breadth of data, right? The more you have, the longer time period you have it for, the better answers you're going to get, right? You need scale, right? Concurrent execution, hundreds of millions, billions of interactions, right? These things are going to have to be nearly real-time response for some of these online services. And once again, we heard a number of people, Microsoft earlier, Bill talked about how many data centers they operate around the world to deliver certain SLAs. These things can have to be globally deployed, but obviously they want to manage the service locally. And so if you look at where this is going to go, we kind of talk about a few pillars here of what a future data center is going to look like. So let's hit the first one. We talked about limitless breadth in data. So today, if you want to talk about storing data on space, there's actually nothing better out there than a hard disk drive. Now, these are kind of things people don't talk about a lot. Some others predict their demise. And I think our Blu-ray jukebox back here is very interesting. But I would be willing to predict that the leaders in this industry, when they focus on this segment, and instead of talking about products that have been modified to work in the data center, but start talking about products that have been architected for the data center, a warm data drive, a cold data drive, an ultra-long store drive, and take the brilliant engineers that they've got and go solve the technical challenge around this, you're going to see that for depth and breadth of data, grained magnetic media and all the technologies that are there for reading and writing that, once it gets power optimized and form factor optimized, will probably be the way to deal with the vast limitless breadth and depth of data that we're going to have to deal with. Now, there's one thing a hard drive isn't, which is the near instantaneous access and response, right? And so if you want that contextual rapid response to these online services that you're not going to wait on, right? If you're a user, you need to get your answer back pretty quickly, or if you're trying to inject an ad, as was discussed earlier, contextually, and in some situation, it's got to happen in a certain amount of time. That's not a hard drive, right? And that's not a gap that's ever going to be cleared. So today, processors, their caches, memory is incredibly fast. As soon as you leave that and enter the storage domain, it's a huge latency penalty, right? 100,000x versus a memory access. Over the last 4 or 5 years, NAND flash has gained a lot of traction and solved a lot of technical problems for a lot of people because basically it reduces that by 100x. And so it's a tremendous accelerator for contextual or hotter data. But as we go forward, this isn't going to be enough or even close. So there's a set of technologies coming. They're called next-generation NVMs, non-volatile memories, that basically span this world between memory and storage to a degree that NAND flash can't. And so there's two fundamental technologies. One's called PCM, phase change memory, that uses an attribute of amorphous or crystalline and heats a semiconductor to enact that change to create a 1 versus a 0. And then spin torque transfer, which works more like DRAM. But essentially what you're going to see is this full hierarchy is going to get filled in. And there's going to be pretty amazing things in transformational and applications and service delivery based on it. And so just as disruptive as flash has been in what can be accomplished in a data center for a set of services, for a set of applications, these next generation non-volatile memories are going to do the same. First, once again, living within the storage domain, normal OS read-write APIs, but later we're working with quite a few partners in the industry now, and we'll get to a few more examples later, to basically make the applications aware of the idea of a load or a store, something that does not go through an OS kernel API that results in a non-volatile exchange, right? It persists across power fail, and that's going to be a very powerful thing for a set of applications, and it's not something you have to go broadly and rewrite tens of thousands of applications. You hit a critical 15 or 20 and enable them with this technology, and you go a long way. So we talked about the data that's coming in, and we've got infinite depth and breadth of it nearly. certain technologies in memories that are going to make this more instantaneous retrieval. But I've got to somehow turn all this data on this media and memories into a solution, right? I've got to actually pack it into infrastructure and deploy it and manage it, right? So now we're on a couple of the other pillars of that first slide. So, and once again, you heard a number of the presenters earlier say, for the really hyperscale guys, right? Once again, Bill brought this up in his speech about Azure. They really handle all the challenges like service availability, the pooling of the store to where it's accessible across a broad part of the compute farm, the reliability, all within the application. They want the infrastructure as kind of simple and basic as they can possibly get it, and they're going to basically handle that all themselves. And that works great if your scale is thousands of racks or tens of thousands of racks. What if your scale's not that big, right? I mean, most of the hyperscale guys have a fundamental assumption that the rack is the failure domain. They don't care about anything within the rack. The whole rack goes away and they're fine. And, you know, once again, from a data perspective, they'll use things like erasure coding schemes and spread code words out across racks so that even if a full rack fails, well, that's one code word of my 14. I only need 10. I could lose 2 more and I'm still fine. Which, once again, at their scale is a fantastic set of technologies and it's the right architectural approach. What if you're not that big? What if you're a hoster, a service provider, a private cloud inside an enterprise, and you've got to make all these things work at a small to mid-scale, but you want to get the value of all the innovation and all the creation that's occurring in this ecosystem? You actually do have to have some cooperation between the application and the infrastructure when you go and deploy at small scale. But a key aha for us at LSI was a lot of the fundamental elements, kind of the hardware things that live under the software and deployment architecture, are actually common for the 2 use cases. So that leads you to kind of what is that software and that ecosystem that lives on top of this fairly similar infrastructure. And if you roll the clock back, what you had was everyone built on top of a product that came from VMware or Microsoft, right? And then as the hyperscale guys grew to hyperscale, they created frameworks to solve this deployment, monitoring, orchestration, all these challenges sort of in-house, which left sort of a very interesting middle ground of if you can't for some reason or don't want to use the Microsoft or VMware solutions or they don't scale enough, but you're not hyperscale, what do you do? And the OpenStack ecosystem is what formed here. And so this was really the linchpin for us at LSI, was looking at OpenStack and saying, this is interesting, right? It's a vector for innovation. We're used to working with the Microsofts and the VMwares, and on the traditional infrastructure side, the Dells and the IBMs and others. But this was sort of a different angle that has a different velocity to it, right? You can actually create innovations and enable them with partners and get it out to market at sort of a much more rapid rate because it has a cadence that's all its own, that's different than the traditional IT service providers. So about 2 years ago, we started going, okay, so this is interesting. It's going to be very successful. How do you actually do it, right? Do you have to hire guys that are maintainers and experts, or do you work with partners? Are there guys trying to monetize this ecosystem and build products and services and support around it like people have done for Linux for years? So we kind of had to go on a fact-finding mission and figure it out. But what we decided was it was definitely worth doing. And I'm going to give you one quick example. So first off was our technology is pretty ubiquitous for storage infrastructure and servers, but we found a lot of people just had friction in deployment. Oh, great, when I go with the OpenStack framework, there's this other tool to deploy the storage on the LSI controller inside the server, and we kind of have to snap out and do something special, and it's really sort of a pain, and we don't like it, right? So step one is kind of boring but important stuff like management integration, right? And making sure our error reporting and diagnostics and all this stuff feed up through the right paths so that the monitoring and deployment tools, et cetera, worked. Second was we realized that this world really is driven around software-defined storage. There's no traditional SAN or NAS in a lot of these OpenStack deployments. which is very functional, but we found often not very performant, right? People have a lot of performance challenges today with some of these approaches. And so we partnered up initially with Nebula and did a demo at one of our events last year, but we have it in our booth, and I would encourage you to come by. That's basically a way to take a rack of servers, disk JBODs, and create fault-tolerant, pooled, shared storage that's completely orchestrated by the Nebula One controller, no separate management, deployment, anything interface for shared storage within the rack without a NAS or a SAN, right? So literally just taking the raw disks and creating pooled, shared, fault-tolerant storage at a rack level under orchestration OpenStack with Nebula as our partner. So these are the kinds of things that got us started, right? So OpenStack, and then that understanding that the common infrastructure from the hardware side, the way all these media and memories map into a solution are the same, led us to Open Compute, right? So for us, OpenStack came first in the software ecosystem. Open Compute came second. And for us, once again, it's that velocity of innovation, that direct interaction. I think someone mentioned earlier, never let anyone get between you and the customer that's eventually going to use your product, right? Because you're not really going to learn, you're not really going to know. So we've invested now to join the community. We're making 2 contributions today. One is our Nitro 6209 PCIe flash design into the community, and the second is a 12 gig expander upgrade to OpenVault. So the first is essentially a PCIe flash accelerator card. So 1 terabyte, half height, half length. This is something that we designed specifically for OCP style servers with their form factor, and airflow across the PCI face is the opposite direction of what people usually expect it to be in the back of the server. So it was an OCP optimized PCIe flash card, and it's a contribution we're making. And then second is the OpenVault storage, right? So when you heard them talk earlier about the cold data facility in Jay's speech, that's all based on OpenVault. The current 6 gig expander inside that is something that we partnered with them on. And today we actually have a technology refresh of that moves it to 12 gig, which the point of this isn't, you're going to go buy a bunch of 12 gig hard disk drives and SSDs. It's that with your current 6 gig drives, you can get 30 to 60% more bandwidth out of the net solution, right? And so with 6 gig drives in the same server, 30 to 60% more bandwidth, and especially on the sequential read side, it's a pretty substantial upgrade, and it's a contribution that we're making to OCP today. And lastly this really isn't all for us. This is part of our fundamental strategy now. So we have other OpenVault enhancements that we're working on and will be contributing. Some flash embedding into that expander board, so you've got some possibilities there. And then we spend a lot of time looking at how to deal with no fault found, false failed HDDs, and have an architecture that we can use to basically do true disk hard reset and recovery integration into the control plane to try and tackle this problem. And then a couple of other things outside OpenVault we're going to do as well. The architecture that I talked about for that rack level shared storage that's under the Nebula appliance, we're going to contribute that reference architecture. We actually have something that's similar to the idea of OpenVault, but it's all solid state based, so you can sort of think of this as a flash vault that's a solid state optimized storage building block. And lastly, some reference designs for our SandForce SSD controllers. And then last on the list, we've had a lot of interest over the years in sort of the traditional experts on RAID and data protection. Was there any part of that IP that we could package and put up in the open source community for people to pick up and use? And so we have decided that is a contribution we'll make. We're going to have to refactor it a little bit because the actual core software today has other people's IP in it to manipulate certain chipsets or controllers or et cetera. So we got to kind of clean it up and make it where we're not releasing anybody else's IP, but we will be in the future releasing some of our RAID technology into open source as well so that people can pick it up and use it. So it's an exciting time for us, and we're really happy to be part of Open Compute and look forward to years of innovation with the community. Thank you.
Thanks, Greg. Appreciate it. All right. Thank you all for hanging in there for 3 hours with us. I hope you found the content pretty awesome. Cole and I are going to take about another hour, close things out. No, I'm just kidding. We have just a couple of quick housekeeping things, one of which is very important to me personally, which is to recognize the project leads. If you could please forward the slide, just go back one. If you would go back one slide, that's great. As I mentioned earlier, the project leads are really the core of this community. As we've had people enter into the project, they want to gain influence in the project, and they're like, we really want a seat on the board of directors. And it's like, no, that's not where the power resides within a community effort. Where the power resides is with the community, with the project leads, with the project teams, the incubation committee, and then ultimately the board of directors does get a vote on this stuff. But where the most influential people and the hardest working people in this project are our project leads. And so with that, I want to thank publicly Rajiv, YF, Mark, Matt, Ashgar, Per, Peter, and Jason for the work they've done. I also want to thank all of our past project leads who have done some of the foundational work. And as a small token of our appreciation, we have a pretty awesome jacket for all you guys. So thank you very much.
Guys, thanks for sticking around. You guys are the troopers here. We've got a really exciting afternoon for you all. You've got a number of options in the afternoon. You can come back here for the executive sessions that start at 2. I'm sorry we're cutting into your lunch. Downstairs at 2 in the lower level, there is the engineering workshops. There's also the Hardware Hackathon that's actually going on. It's in the process of being started right now. So if you're interested in getting your hands dirty, then head over to the hack. It's right over here. And then tonight, stick around. We've got a great cocktail party for all of you. I've heard there's going to be a dancing penguin. The OCB Foundation
is...
Yes, it's not Frank. But really exciting day, really exciting evening. Please join us tonight. Thank you very much for coming. I want to close with a friend of mine said yesterday, he was quoted, "It's better to be at the dinner table than on the dinner menu." And we think by everybody's participation here, and that's true in all things, right? We think everybody participating here, you guys are at the dinner table with us. It's awesome to have you guys. Really appreciate it. Thank you very much.